Hello and welcome to the Neuroscience Office Hour with Suzana Herculano-Houzel. That's me. Today is April 4th, 2023, and you are hearing me live from my virtual office at the 880 studio in Nashville, Tennessee, where I am a neuroscientist working as an associate professor at Vanderbilt University. Since this is my first live Neuroscience Office Hour in English, I want to start by talking about what exactly is this neuroscience thing, and also what or who is a neuroscientist, besides, a person who does neuroscience. So let's start with the modern all-inclusive definition. Neuroscience is any form of scientific research that cares about what the nervous system does or should do but stops doing, or how the nervous system comes to be. Which means that to explain what neuroscience is, I must first make sure that we're clear on what scientific research and nervous system are. So let's start with scientific research, or put more simply, doing science. Science is a very methodical process of building knowledge by observation, guided by questions that take yes or no answers. It's actually very much like that game of 20 questions, with the difference that you never know how many questions it will take to find a good, satisfying answer to your problem. Which, by the way, explains a naive question that people have. Why can't scientists simply discover how diseases happen or what causes a new disease like COVID? The answer is that scientists don't say, today I plan to discover what causes COVID. The process of science is like playing 20 questions, so it starts like this. All right, new disease. Is it contagious? Okay, yes, it is very clearly contagious, because if you lock yourself at home and don't see anybody, you don't get sick. And on the other hand, stick a bunch of healthy people in the airplane with one sick patient, and a few days later, many of the healthy people aren't healthy anymore. So that's done. Next question. You'd hope that the next question is, what is the contagious agent? But that's not how science works. Remember, it's a game of as many questions as it takes, where you only get yes or no answers. So a good question instead is the contagious agent a bacterium? Are there bacteria of a certain type that you find in all patients that correlates with who gets sick and who doesn't? The answer is no, not a bacterium. So next question, if it's not a bacterium, is it a virus? Yes, if you collect samples and process them looking for viruses, which is very different from how you process samples when you're looking for bacteria, you do find viruses, and lots of them in the sick people and none in perfectly healthy people with no symptoms that also remain healthy the following days. Okay, good, virus. Next, a treatment. You can't just say, I'll mix reagent A and reagent B and get drug C. That should do the job. No. Remember, it's 20 questions. You don't know what you need to know to develop that drug yet. All that you can do is ask questions and do the experiments or the observation that gives you very simple yes or no answers. So, does drug A have any effect? No. Also, no drug that looks like A has any effect, so scratch A. What about drug B? Does that help? Also no. Hey, we learned ages ago from another game of 20 questions that there's this class of inhibitors of viral replication that works for stopping herpes outbreaks. How about we try that? Does that work? Yes, wonderful, it does. So the persons who do that for a living, who play these very elaborate games of 20 questions, or rather as many questions as it takes to find things out, are scientists. Can anybody be a scientist? In principle, yes, of course. Everybody has the capabilities required to work as a scientist, and I really mean to function as a scientist. That is, the capability for observation and memory of what you observed, for setting goals and making plans of what to do to get there. The capability for trial and error learning, meaning that you come up with things to try and see if they work for what you wanted to do. The capability of logical and deductive thinking, and also creative thinking for piecing together those yes and no answers into a story that makes sense, but that is itself testable. Because if it's not testable, if it can't give you yes or no answers, it's not science. Examples of what is not science: anything that is a matter of belief and therefore can't be questioned, like religion. That doesn't make religion better or worse than science. They're just two completely different things. One, religion, is a closed system of beliefs where people agree on what story they want to go by. The other, science, is an open system of questions where people continuously disagree on what is the best narrative, and it's actually their job to keep asking questions. Which means that being a scientist is also tough work, because it's part of the game that people continuously disagree with you. And that is a good thing, because 20 questions, remember? So if nobody disagreed, if nobody had different suspicions, you would be playing all by yourself, and the knowledge that you create would grow very slowly if it were all up to you to challenge yourself all alone. So yeah, scientists need to be able to take criticisms well, and always understand and remember that a criticism to their ideas is not a criticism to their persons. It's okay to be proven wrong. That means that you can move forward to the next question. And some people have a hard time keeping the two things separate, and that's okay. There's plenty of other things that they will find that they enjoy doing. We need scientists in the world asking questions for a living, but not everybody needs to be a scientist. Also, in practice, science is arduous and sometimes incredibly repetitive work. It takes patience and grit and persistence, and sometimes crazy optimism. Remember, it's not a game of 20 questions and you're done one way or another. It's as many questions as it takes to get to a satisfying answer. And the best or worst part, depending on how you see it, is that this is a never-ending game, because chances are that every time you get to an answer, that just means that you now have 10 new questions that you didn't even know that you had before. And this to me is, of course, the best part, because the biggest pleasure to me is not in getting an answer, though that is, of course, very satisfying, but it's really the thrill of the process of asking questions and feeling that you're getting closer and closer to making sense of the problem that got you started. So let me give you an example. A couple of years ago, I discovered, by playing around with my data and paying attention to what I could see, I discovered that body size, which everybody still used as a predictor of lifespan across species, was actually a lousy predictor of how long different species live. In what seemed like noise in the data, I actually saw a pattern. I noticed that for a similar body size, birds systematically lived longer than primates, and primates systematically lived longer than other mammals. That is a pattern. But I also remember that that was a pattern that I had seen before. For a similar body size, birds have systematically more cortical neurons than primates, which have more cortical neurons than other mammals. You see the parallel? So I had a new problem right there, a perfectly good yes or no question. Could lifespan across species simply be a function of how many neurons they had in the cortex? Meaning, if I lined up warm-blooded species by numbers of cortical neurons, would I find that the more neurons they have in the cerebral cortex, the longer they can live? Yes, and it was this beautiful correlation that you see on the screen. The more neurons a species has in the cerebral cortex, the longer it lives. Oh my God, that was so thrilling to find, and instantly I started thinking of a number of new problems. How could that possibly happen? Is it really the number of neurons in the whole cortex, or is it a particular part that matters, like the hippocampus? Or is it actually something else that matters and that just so happens to also correlate with the number of neurons in the cortex, which was what I happened to be looking at? Each of these new problems requires its own whole new set of yes or no questions, which are what we call testable hypotheses. And that's where I am now. I have a bunch of testable hypotheses and now must get to work on designing experiments and tests and observations that will give me yes or no answers. It's arduous work, but it's really fun work. Well, for those of us who enjoy being riddled with never-ending questions. So that covers the science and scientist part. Now, on to the people who specialize in asking questions about nervous systems or systems made of neural cells or neurons. These people are neuroscientists, not neurologists. A neurologist, like a cardiologist or a dermatologist, is a physician, but a physician who studies problems with the human system made of neurons, which is the brain. I am not a neurologist because I am not a physician. I am, however, a doctor in neuroscience. But we'll get to that part soon about who is a neuroscientist or what one must do to become a neuroscientist. Before that, though, we have to finish what we started, which was explain the two parts of what is neuroscience. We did the science part, which was that game of as many questions as it takes, which means that a scientist is a person who asks those questions professionally for a living and becomes very good at figuring out what are good, useful questions. Now, what about the neuro part? What is this nervous system, and what makes it so important that there is a name just to describe the people who care about it? And by the way, there wasn't always a name to describe that. The brain is an organ full of blood, and that has always been very visible as soon as heads are cracked open, which happens in battle and when enemies or predators strike, two things that humans have been pretty prone to. But it took somebody asking those pesky questions about brains and how they worked to realize that brains had all these bundles or cables connecting them to the body. The word in Latin for cables or tendons or sinews is nervus, and the word in Greek is neuron. So a nervous system is literally the ensemble of cables that run through the body, and it is made of nervous cells or neurons. Now, plenty of people had been studying nerves and neurons and what they did, but usually as part of some other activity. They were physicians interested in curing or at least treating people, or they were anatomists interested in understanding what are the parts of the body, or they were physiologists interested in understanding how the body worked. Some of those physiologists became particularly interested in understanding how come humans behave the way they do and what is the logic of the human mind or psyche. So soon, those types of physiologists started calling themselves psychologists. And yes, they used to be physicians, so a psychologist used to be literally a physician of the mind. And since that term was already taken when a different type of physician of the mind came to be, that new type was called psychiatrist. And nowadays, a psychologist is typically not a physician at all. Psychology and psychologists really became recognized as a thing in the early 20th century, which was also a time when biology was booming thanks to a number of new methods and technologies, the really only tangible upside of the literal arms race that humans engage in when they go to war. Suddenly, in the mid-20th century, it became possible to probe living beings in ways that had never been possible before, which dramatically changed the nature of the questions that could be asked. Because remember, the game still is 20 questions. And it soon became crystal clear that the brain, when there is one in the nervous system, was the core that embodied all those things that physicians and anatomists and physiologists and psychologists had been asking questions about. How we function or don't function. How come we do the things that we do, all anchored in the biology of the nervous system. So something like this was probably happening at the same time wherever scientists of different sorts were interested in brain-related questions, but we know that in 1962, Francis Schmidt, a physiologist, biophysicist, and electron microscopist at the MIT, founded what he called the Neurosciences research program because he recognized that blending and integrating concepts and methodologies from different fields of science, from different types of science, was going to be critical for answering complex questions about such a complex thing as the relationship between brain and mind and behavior. The Neurosciences research program that he created after calling a meeting with a number of scientists with shared interests but different fields of expertise was this interdisciplinary joint venture. So that was 1962 and the name stuck, which goes to show that more and more scientists were ready to identify themselves with this new unit of interest, the nervous system, and how it produces behavior, thoughts, feelings, how it forms during development, how it came to be the way it is over the course of evolution, that's my own specialty, and also how it doesn't work on occasion and what can be done when that happens, or what can be done to prevent that from happening and keep the brain working for as long as we can. These people call themselves neuroscientists. I, for example, am a biologist turned neuroscientist. So, last part for today. How does one become a neuroscientist? Hopefully by now you see already that there are many paths to becoming this type of scientist who asks questions about the nervous system and what it produces. Also, becoming a neuroscientist is typically something that happens after you have gotten your basic college education. You can start out as a biologist, zoologist, chemist, pharmacologist, also as an engineer or physicist or data scientist, and also as a psychologist. You can also become a physician first, then dedicate yourself to neuroscience. These days, more and more universities also offer a major in neuroscience itself, though that's often really a pre-med major in disguise. In any case, don't be fooled. If you want to become a professional neuroscientist, you will need years of dedicated learning and training in how to ask questions productively and learning the tools and methods at your disposal and how to work with them. That training is offered to you systematically in packages called graduate school, a 4 to 6 or sometimes 7 years process of intense supervised work and training, at the end of which you earn a PhD. 3 letters that mean that you are now a doctor of philosophy. and also most likely unemployed, but ready to get a job. And what can that job as a neuroscientist be? That will be the subject of another live of the Neuroscience Office Hour. I'm Suzana Herculano-Houzel, your neuroscientist on call, and I am always happy to take your questions. So subscribe to the YouTube channel, watch the next live, and ask your questions directly to your neuroscientist on call. That's me. You can also follow me on Twitter at SuzanaHH and on Instagram and TikTok using the links below, and you find plenty in my Twitter feed. And if you really want to know more, try my site neuroscienceconcepts.com, where you can learn neuroscience your way at your speed, focusing on the important principles and concepts, not the details. I'm Suzana Herculano-Houzel, your neuroscientist on call, talking to you from my virtual office at the Neuroscience Office Hour. See you next time.